final stretch before the glass of wine. We'll see if we can pose some hard questions. So, when I think about innovation, the simplest way that I have in my head to think of it is that it's about marrying a customer or need insight with a technology or solution insight. It's the feedback loop between those two areas. So I'm going to start with two questions before I turn this over to the audience, one on either side of that innovation puzzle. So the first is something of a rhetorical question, is about understanding of the future trajectory of the ocean economy and how that feeds in to determine the technology and ocean information needs. So how do we improve our understanding of one side of that innovation puzzle so that we can more effectively marry the technology or solution insights we have to address those problems? And it's something that some of you touched on earlier in your talks. Who wants to have a go at that? What can we do to better understand? Obviously, events like this will help us. What else can we do to better understand the, if you like, the demand side of the innovation puzzle?
Perhaps I'll make a start, but I think it probably should be from our colleagues here who really have the real challenges to face with. I think there's a couple of aspects here. One is that an understanding of the problems are really key, and as well as an understanding of the opportunities that come about from some of the emerging technologies or solutions or reuse. There's a famous phrase that innovation is a contact sport. You actually need to put people together. I think what we're seeing is that some of the technological innovations that are driven from a commercial need in some sectors have the opportunity for being exploited and brought to good use in other sectors as well. Before I pass on the mic, just a thought that came through my head earlier. We have the aspect of the science, the technology and the innovation, and it's captured in the essence of the forum today. Science informs our understanding of the environment. That should inform our policies. Our policies should set the regulation under which we are challenged to be good custodians of the environment and bring technology to effect. So I think everybody has a role to play here, both in terms of science and government and us in technology.
Good question. From a NOC perspective, we are largely here to do science, and we're largely here to support the UK science community with infrastructure such as the Marine Autonomous Systems fleet that you saw earlier. I'll give a couple of examples of how we've extended the reach and influenced other sectors and hopefully benefited other sectors. With DEFRA Group and with the MOD, we've worked with them on joint projects where it's been all about getting assets in the water to solve a common problem, where the nexus of science and policy joins up really nicely. So understanding the effectiveness of marine protected areas was one example that I spoke about. Another one was how do we get this best composite picture, how do we merge different data sets in real time to get the best intelligence from a cube of the ocean, primarily for the defence end user. So a couple of mechanisms that really worked with that. One is we actually invited during MASMO missions the MOD stakeholders from the Navy, DSTL and other parts of the MOD to come into the operations room and see a live mission with autonomous platforms with real-time data coming in. And I have this mantra of seeing is believing. I think that was transformative for them in terms of understanding what benefit that data could provide to them and help drive solutions that they required. And with DEFRA, we had staff exchange between the DEFRA and various agencies and NOC. And that Darwin Mounds expedition that I talked about earlier had DEFRA Group staff from the statutory conservation agencies on board, working with our scientists in synergy. So again, they can get confidence that these new platforms are delivering data that meets their requirements. In terms of industry, I think originally today there was reference to the innovation centre that we have at the NSC, where we have about 30 industry partners, and there have been a number of Innovate UK projects and mechanisms to bring the engineers working in that Mars team together with industry partners to develop new projects like products like the EcoSub and coupled surface and submarine systems. So I think you're right. I think it's all about mechanisms for bringing people together, and I think the more we can do that through parts secondments, joint missions where everyone comes in a very open way to share data and information, and maybe that's the role of organisations like NOC, is to act as that honest broker where we don't have a commercial stake and we can provide some independent information and advice to inform how end users can take it forwards.
About sensors. Excuse me. So in terms of sensors, one thing we've noticed is that some research institutes and universities are better at engaging with industry than others, and there's a big plus to be had at engaging early on. So for example, the Sussex University guys with their quantum sensor, they weren't really thinking oceanography at all when they started that programme, but they were introduced to us actually through the Innovation Centre. And so we were very early on, we were just able to wave a flag and say, when you're thinking about developing your sensor for whatever, it might be automotive, aerospace, or even pharmaceuticals, just think about what our needs are, because you might just be able to design something which is small and low power, which wasn't perhaps at the top of your spec list. And by doing that, we as a group, a fairly small group in that sector, even if you include the defence, we likely to get some kind of useful technology coming out of other programs which weren't really envisaged for us. So that's been a very important thing.
Just a couple of comments on the sort of understanding the need and the pull. And I've got a couple of examples of where I've done this badly and I think I've done it well. And it takes time and patience and lots of questions. So a kind of a bad example is certainly one I've had in the defence industry, where customer X thinks they need something, they come and talk to a company, you have a meeting, you ask a few questions, you both go away, make some documents up, you agree a spec, you pat each other on the back, you've done a really good job, you build it, 3 years later you finally deliver it, the systems are put together, you take it to sea and it's not really what they wanted at all. They've learned a lot and you've learned a lot and you've wasted a lot of time. So I've seen a lot of defence projects where not enough time is spent really getting to the bottom of what they really need. On the flip side, on the sort of commercial side, we did a project with a hydrographic survey company and we spent a long time together really talking about the problem and agreed that we'd actually just go and try a really rapid prototype. So we worked together on something in about 3 or 4 weeks, got it to sea, trialled it, came back with a lot of lessons, a lot more experience of what we both really wanted out of the project, then wrote a spec, built something that worked. So I think the kind of the patience to keep asking and asking and asking, because what they think they need initially is rarely what they actually need. So yeah, time and patience.
Yeah, we work sometimes as a consultancy for some companies. We are academia, but sometimes they come to have something, and especially the insurance companies, because if you have your stuff in the middle of the ocean and you want to know now if a storm is coming and you want to know in an accurate way if it is coming, so they are really interested in founding this kind of research on these technologies. And on the other side are also the all these like autonomous sensors that we have seen now, no? How it works, usually they have like a track they have to make, like so it is like a forecasting. So they know each time step where they have to go. But also in that case, they have like when you put the track on the sensor, so anyway, even from the office, if there is a radar, but sometimes you don't find them, so they are like completely independent for some hours. If something happened that was not previously predicted, so it can be lost or whatever. So what they are interested is also in these kind of new technologies for assimilating new data, because on top of, on the chip of the sensor, they can like have an external material sensor that can collect new data and adjust the trajectory of the autonomous sensors that is going on. So this, at least these two kind of.
Okay, so now I'm going to probably come back to the slide that Terry very quickly glossed over, because I didn't manage to read the first couple of sentences before you glossed over it. And that's the other side of the equation, and that is the barriers to innovation happening at all. So what are the barriers to innovation in support of the needs of the future ocean economy, and how might we overcome them?
Generally, it's boiled down to funding, of course. There are very, very few, certainly in our sector, there's very, very few companies large enough to invest in the kind of high energy research required for some of the new sensors. So that has to be done, or it is done in universities and institutes where they've got access to larger pots of funding. The controversial point is that some institutes and research and universities are very good at letting go of that into the commercial world. Others are not so, because the pressure is on for them to write for a grant application, get some funding, spend it on the research, write a paper to get more funding, to do more research, to write another paper, and it's very difficult to liberate that technology when it's commercially deemed to be commercially viable. So that's a problem. If the engagement was very much more along the lines of Innovate UK or UKRI, where very early on there's contact with an SME or a commercial outlet, then that tends not to happen, because there are a fixed deliverable, fixed time scale and a fixed budget, which in the commercial world is just everyday stuff. But in academia and research, it's not the case. And I'm talking quite generally there. So
it's the early engagement.
Early engagement with
challenge.
A goal in mind, and not just to continually do research.
Anyone else have a view?
I think there's been a number. I mean, what's encouraging today is the slide packs presented by several people featured platforms that have resulted directly from Small Business Research Initiative or UKRI or Innovate UK funding that brings together academia and industry. I guess my observation is that we're actually pretty good at innovating in this space and getting things up to the mid-TRL levels. I think that we're not as good at other countries at taking them through to a commercial product at the high TRL levels, and that's where we're missing funding mechanisms that actually take stuff into an operational or commercial ready platform or sensor. And I say I think that's something that some of the industry bodies represented today could look at, because certainly my observation is we're good at innovating and generating a new product, and everyone says, wow, that looks great, that's going to be brilliant. And then the companies involved are then struggling to go through what I call that bomb-proofing phase, where they get up to a TRL 8-9 product that's ready to go to market. That's taking too long, and I think they're finding it too hard to get capital to support that phase.
So I'm sure Dan will comment on that, because in my book, innovation is that whole process. It is not just the first pieces of it, and the latter stages of it are in many respects more difficult than the initial stages, but I know that you have a view on this as well, Dan.
Yeah, I think you're right. You see so many projects finish at that, here's a glossy great picture and a video and a paper and a poster at an event, and you've only really just a tenth of the way through the journey, building the next few that are built for production, not for prototype, doing the documentation, doing the training, doing the templates to fit it to your ship, all these other things that might need doing, which maybe aren't seen as quite as sexy or as glossy or as innovative, are a part of that innovation. You know, if that innovation is to actually change the world, change someone's business, change someone's life, do something useful, you need the other 9/10. And there is, Terry's point, there's lots of funding available for that first 10th, which is build your proof of concept, build your proof prototype, simulate it, test it in a tank, test it in a lake, test it in coastal seas. But to go and test it in the Bering Sea, to go and test it in the North Atlantic, then to build some for production, and then to support some users is 9/10 more work.
So I think we've got a linguistic problem with people's understanding of what innovation actually means. And I think that's particularly the case in government. It's too often thought of as being those first few stages and neglecting the latter stages, which are a much bigger commercial challenge. There's lots and lots of ideas. It's hard, but it's not that hard to turn those ideas into something.
Yeah.
But taking that something to a market or an application is a hugely challenging step. So I'm going to throw it open to the audience.
So just following on that particular item, I talked about getting the government to invest to get all the way through to that end. And part of our lack of funding, I think, is that we need to make that case, but not just to the government. It's got to be a little bit beyond that, because even the government is short on cash, because we've had tax cut after tax cut in our country and austerity plans in other countries that have tightened the money that's going to some of those institutions who are capable of building some of these innovations and getting them all the way through those tiers to where they're at market.
Can I take them on? I agree completely. I think if in the UK, if we have the aspiration to achieve 2.4% or 2.6% of GDP in R&D, and where a lot of that is going to be driven by industry needs those support mechanisms. But it's also not just about doing the work, it's about creating the commercial imperative for this. And that is a whole aspect of willingness to invest in taking things through that final stage. And that means those investment mechanisms need to be there. But when we're talking about something as vast and global as the oceans, and we're looking to change behaviours at the global scale, whether it be for reduction in pollution or protection of the environment, it needs to be taken to that level, at the global level, at the regulatory considerations with regard to how do you operate in these shared spaces. And there needs to be the frameworks which create the imperative for investment in the technology and bringing them to market. There needs to be that join up from we must do this, and in order to achieve that there must be financial incentives or penalties to bring it all the way through from an idea, from a demonstration, to actually seeing an impact on the bottom line for global economies.
Yeah, just a point to add. I guess in the really early stages of any science or technology, the very fundamental level, the very high risk level, that absolutely expect support from the government. And that is high risk. A lot of them aren't going to work. Fantastic opportunity to work with government. As the idea, the science, the technology, the design develops, and it gradually becomes less risky, you would expect private industry, equity investment to come in and take more and more of the risk. And that has been, I don't have tons of experience of it, but the limited experience that I've had of that phase is the marine industry is just not that good at it. I saw some sort of pitches from some automotive companies, and the companies have got some great tech around sensors, and they had fantastic statistics for the car industry, from all the manufacturers, all the geographies, exact predictions of number of cars and type of car. They had all the market data to make a really compelling argument for why they were ready for investment. The marine industry is just so diverse, and it's just such a huge number of topics and applications and geographies that I think we're not very good at getting this data to make our case as a generalism industry. So I think we do struggle with that investment compared to others.
Other questions from the audience? Is everyone so saturated with information now they can't think of anything else to ask? The one back there, Mark.
It's with regard to the funding mechanisms, really. If you look at offshore wind, without the government investment in the carbon trust and actually driving costs down, it wouldn't be competitive for where it is today. We have a number of societal challenges that have been recognised by the government. Perhaps the government needs to look at an ocean trust to actually address some of these issues.
responses to that?
Not necessarily specifically, Mark, but I think there's an argument there is a lack of funding post Innovate. So if you get through an Innovate process, whichever one of the funding models are used, and you're successful and you have a product which is at TRL 7 or something and needs that little bit of a kick, the only real avenues open at the moment are private ones, which are not always commercially acceptable. What's lacking is a government model that at that stage the whole thing's really quite de-risked. A government model to provide some funds to get you through that value and see a return on it, but with no huge outlay. So the initial funding is not enough because you have to be able to afford to accept the funding, because it's let's not forget it's partial funding, it's match funding. So once you get to that stage, now I was having a discussion with a chap who's doing a master's in this, and that's his topic, and he suggested to me something like a student loan model where government at that low risk level would give you a chunk of money to get you past the valley of death, knowing that there's going to be a return on that investment that you pay back when you could afford to pay it, rather than commit yourself to debt financing early on, which is just going to sit on your shoulders all day and keep you awake. So I think, not really the answer to your question, Mark, but there's a missing link in the whole process, which kills a lot of that early good work ever getting to be really, really successful.
I agree.
Because that debt financing can very often strangle the whole process.
Absolutely, yeah. So you've got to be able to afford to take these funding options on day one.
We've got time for perhaps one or two more.
I think you're right about that gap, because as an end user, a commercial end user, I can't take the risk in buying that not finished product, because you can pay for it. I only get a return on my investment if I deliver the data thing that generates. So there's that sort of reluctance as well as the risk share. So we seem to have reverted from the acceptance that this is new, it might be better, let's give it a go, right through the commercial model. So that's our end users, customer, the survey or whatever user of that new innovation.
You need to transfer that risk onto your clients.
Well, not transfer,
or share.
Share.
Yeah.
But everyone is so risk averse these days that there has been a change in risk acceptance that's come through the
It's true. There
science
is
marketplace anyway over the last 20 years.
There is a phase in that process of going from through TRL levels where you and as we've done, we've worked with early adopters and generally in academia, and they're able to independently take that technology and wring its neck and see what it can do and what it can do for them and use it. Masmo's a good example. Get it in the hands of users early on. So it's very, absolutely right. We need to de-risk it for the real end users, science, commercial, and the
No,
defence.
I can't actually de-risk it, because that's just bouncing it back to the innovation end. It's the acceptance that there might be some risk through the user, further into the user group.
Well, that's
Can I just take the matrix as I've been shanked? I think we actually need to take a slightly more positive note here. We've heard some fantastic things today about the technology, the maturation of this, and how it can solve some really big challenges. And we're almost at a tipping point here, where we're seeing the conjunction of different sensor technologies, of automation technologies, of data processing and analytics technologies, where we can have a better understanding of what's happening in the oceans and how to put these technologies to use for societal benefit. I think there are changes required in terms of regulation, and rapidly so that we can actually see these things being put to use. Because by taking the human out of the dangerous environment and getting better information, we can actually make the oceans actually a viable, sustainable place for the future of humanity. I mean, it's big picture stuff, but really what we need to do is changes to the regulation for autonomous systems, for support for the innovation translation process to scale up and to do it here in the UK and take a significant lead. But from everything we've seen today, there's a great opportunity for seeing this all come together.
Unless there's any other, I'll go ahead.
So on a note of positivity, just a little anecdote. So the image that a couple of people showed of all of the shiny yellow things in front of our research ship outside the NOC, we were very proud of that picture, and I remember Professor Gwyn Griffiths, my predecessor who had the Mars team at NOC, at a quite high profile event, I think it was at the Royal Society, put that picture up and said, well, what's wrong with this picture?
They're all on the top side.
Exactly, people remember that. So that stung me, actually, and it was a good challenge, it was a valid challenge, and it certainly stung me. And there was a moment a couple of years ago, it was midwinter, and I was taking a group around the Innovation Centre at NOC, showing them the glider hangar, and it was pretty empty. It was something like January. And for me, that was really satisfying, because it showed that we'd initially invested in the assets because we had capital funding from government to pump prime science capability in that area, but it took time for the scientists to, you called them early adopters, but it still took that bit of time to get their confidence up, to write them into their research grants, to replace their conventional methods of getting data. And we got to a point where, I think a couple of winters ago, we had something like a dozen projects that were funded by NERC and EU that were using autonomous assets from pole to pole live on any given day, and this was in the middle of winter. Everything from stuff in the South Atlantic through to the Arctic. So that took a little bit of time. What it's done is it's enabled us to deliver to the UK science community a competitive advantage on a global scale. So we are punching above our weight in marine science by a long way, because we've got this support in terms of the technology, ships, marine autonomous platforms, observing systems, etc. So the science community can get away with using stuff that is at TRL 5, 6, 7. It doesn't need to be 8, 9 to get a nature paper out of it by doing something for the first time, like 3D mapping of a canyon. So I think there's a positive note there for science. I accept that's different if your end user is in industry or other sectors, but certainly for science it's made a real difference, that capital investment, but it did take 2, 3, 4 years to pull through to being used routinely by the science community.
So I think we will end on that positive note. I think we've had a fascinating day. We've heard a lot about some really great opportunities, and we've heard a lot about the technologies and capabilities that might help us rise to the challenge of those opportunities. It just remains for me to once again ask you to thank all of our speakers. I would once again thank our sponsors, and I thank you, the audience, for being here and asking questions, engaging in the dialogue in the breaks. That's what this is all about. You'll all receive a questionnaire about this event. I would be very grateful if you would fill that in, because it allows us to look at how we improve future events. We're going to be capturing the outputs from today in some way and disseminating. We'll certainly be disseminating the presentations where the speakers will permit that. So now I invite you to take a glass of wine and view a short film. Thank you very much again.
Thank you.